Hello friends, welcome back to my YouTube channel by computing underscore teacher. And in this particular video, what we are going to do is we are going to check whether a number is a palindrome or not. Okay, so what's a palindrome? A palindrome is a number which when read from left to right and from right to left is the same. So if you look at this 121, you read it from the left hand side 121, and when you read it from the right hand side 121, both are the same. Therefore, it is a palindrome. Okay, DROME. Okay, spelling error. Palindrome. And look at the 6652. This is not a palindrome. Okay, why? Because when you read it from the left, it is 6652, whereas when you read it from the right, it is 2566. Therefore, it's not a palindrome. So in this video, we will create the logic for this, right? So if you like, then please share and subscribe to this channel, and you will be benefited, I'm sure. All right, okay, so let us try and create this palindrome. So in order to check if a number is a palindrome or not, okay, to check if it is a palindrome or not, my first requirement is that I need to have something which is the number. All right, then I need the reverse of this particular number so that I can see and compare whether this number is equal to the reverse of the same number or not. If this condition is satisfied, then I will say that yes, it is a palindrome, otherwise it is not a palindrome, right? The funda is very, very simple. Okay, now the question is, how do I reverse a number? How do I reverse a number? Now before this, what we'll have to do is we'll have to see, okay, how a number is formed. Okay, so if I write a number, say for example 1221, all right, this is my number 1221. So what is the place value of this number? This is the units place, that means it is 1. Now this one is the tens place, right? That means it is 10 times this particular value, and therefore it is at the 20, the place value is 20. Now what is this? This one is 100 times, which means it is 10 times this particular place. This is 10 times this units place. So every time you keep on moving from the left to the right, you are doing 10 times the previous position. So 10 times the unit place, you get the tens place. 10 times the tens place, you get the hundreds place. 10 times the hundreds place, you get the thousands place. 10 times the thousands place, you get the 10,000s place. This is how a number is formed. All right. Now, when we are reversing number, we will have to use this particular concept of this place value, and we'll see how. All right. Okay. Now let's move on. So the first thing that I have identified is that I require a number. So that means I require the user to input a number. Okay. Let us see how we can frame this algorithm step by step. So we will take the input of this number. All right. Okay. Now, the next thing that I will have to do is I will have to reverse this number. Okay. So if I have to reverse this number, that means what will I have to do is I will have to extract this units place, this number digit from this particular number one by one. So first time I have to extract this particular digit. Second time I have to extract this digit. Third time I have to extract this digit. And finally I have to extract this digit. All right, again there is some maths over here. Now for this extraction, let us see how I can get this number. Now in order to get this, if I recollect my mathematics, if I take this number 1221 and then I divide it by 10, what do I get? I get 1221, right? So if I multiply it is 120 times, I will get 122 into 10 is 1220. Okay, if I do this, 122 times 10 will be 1220. All right, what will I get? I'll get the remainder as 1. Now in programming, I know that the mod operator will return the remainder. That means that if I, and this was my number, right? So if I mod this number by 10, I will get my remainder. That means I am in a position to extract this digit, the units place. So if I want the remainder, what will I do? I will modulus the number by 10. Okay, so in step 1 I have got this particular number, and I also know that repeatedly I can get this. Now the problem is that to extract this particular digit 2, I require my number to be modified to 122. Okay, now if I look at this, I see 122 is my quotient. Now, which is the mathematical operator or arithmetic operator that I can use in Python in order to get the quotient? That is my double slash operator. This will return the integral part after division. So it will return 122. That means I can get 122 from my this mathematical operator or arithmetic operator. This will give me 122. Now from this 122, if I again apply this modulus 10, I can get my last units place, which is 2 in this particular case, right? So after that, again, when I take 12 and then again I 122 and I take the arithmetic operator double slash, then what will happen is that I will get 12 from it. Then again I can, so that means I can continuously keep on repeating this. I can continuously keep on repeating these steps so that I can keep on extracting the number, reducing the number, extracting the number, reducing the number, until and unless I get my last extracted number, right? So if you think, when I continuously keep on repeating this, right, and I have extracted the last units place, what would my original number be? Will it not be 10? This will be the last number, and I will take the modulus of it final time. So 0 times, give me 0, and the remainder will be 1. That's how I'll get that last remainder. That means my quotient is 0. So if my quotient is 0, that means my num has reduced to 0. That means this gives me the final terminating condition that I will repeat as long as my number is not is equal to 0. So first my number was 1221. Next time my number became 122. Next time my number became 12. Final time my number became 1, and then ultimately my number became 0. And this is when I will have to stop my repeat. Otherwise it will be an infinite loop. So this is my terminating condition, or the for the while, because I do not know how many times the repeat has to be done, how many times I have to repeat. Therefore programmatically I will use my while. So I have my condition as well, while number is not equal to 0. Now the challenge, I know how to extract the remainder, but the challenge is to frame my reverse of the number, right? My reverse of the number. So how my reverse of the number will be framed? So the first time, if you notice, my remainder that I am getting is equal to 1. Okay, so that means my reversed of the number will be is equal to the previous value of the reverse multiplied by 10, and I will add the remainder with me that I have received. That is how we saw a number can be formed, right? Because the previous number is 10 times its units place, then that number will be 10 times its tenths place, hundreds place, and so on. And therefore what will happen is, after I take my remainder, I will frame my reverse of the number as reverse multiplied by 10 plus I will add my remainder. And this whole thing will be repeated as long as my number is not equal to 0. Right? Now I have the reverse of the number. I will have to check if the reverse is equal to my original number or not. If this is the case, then I will print it is a palindrome, else I will print it is not palindrome. Okay, logic is simple. All right, but there is a problem over here. I have to check it against the original number, but if you notice, my number is reducing and finally becoming zero. That means the number that the user had entered as 1221 is no longer 1221. It has reduced and gone to zero. That means I need and another variable, say chk, which will keep a safe copy of the original number. So instead of checking it against number, I should check it against chk, the copy of the number. Now the logic works because chk is 1221. However, after every iteration, my number has moved down to 0. So the original number does not exist anymore. Okay. So this is the logic how we can create and check, create the reverse of a number and check if the number is palindrome or not. Okay. Now let us do one thing. Let us check this whether our algorithm is correct or not. And how to do that? We will check it with a trace table. Okay, we will create a trace table for this algorithm and we'll see. So for creating the trace table, we'll go one step at a time. So let's take our first variable, which is num over here. So num, then we have got chk. Okay, so let's do one thing. Let's start with chk because that's just a copy of the original number. All right, then I have my rem variable. All right, but this rem, rev and num, that will work only if this particular condition is true. All right, so before that, let us do one thing. Let us check the variable truthfulness of the condition. Okay, so let us check the while condition whether it is true or false. Then we will see the value of a rem what it is, then we will see the value of a rev what it is, then we will see what is the value of current num. So num is already there. All right, so finally let's check whether what the output is going to be. Okay, so let us say that my number is 121. Okay, let's take a small number. Now chk will be equal to 121. All right, now while number is not equal to 0, yeah, this condition is true, that number is not equal to 0, so it is true. So what happens to rem? Rem is number modulus 10. So 121 modulus 10, my remainder will be 1. Now what is rev? Rev into 10, but what is the original value of rev? We don't know. Okay, so that means we require one more thing. So rev is equal to 0, so that we get the original number. Now you see what is the usefulness of a trace table. So until now we were assuming that the algorithm is 100% correct. But see, trace table has told me that there is a missing variable, rev is equal to 0. All right, this is the benefit. So now what is the value of rev? So 0 times 10 plus 1, okay, which is equal to 1. Okay, so rev is equal to 1 right now. So now we'll go back to the loop condition and check. Okay, now before that, num is equal to num 10. So num is 121. So I will receive 12. Okay, as my return value of num 12. Now check the condition. Is it number equal to 0? No, it is still not equal to 0. So the condition is true. So my remainder will be equal to 12 modulus 10, I will get 2. So what is the reverse of the number? So my previous reverse of the number was 1. So 1 times 10 plus my remainder, which is 2 in this case, which is equal to 110 times is 10 plus 2 is 12. Okay, see, I've got 1, 2. Now, next, num is equal to num again divided by 10. So 12 divided by 10, I will get a 1. See how my number is changing from 121 to 12 to 1 now. Now we will check whether my condition is true or not. Yes, still it is not equal to 0. So my condition is true. It will go back and my rem modulus 10. Okay, so the reverse of will be is remainder will be equal to 1 again, and it will be 12 into 10 plus 1. So it is 120 plus 1, 121. Now you see how the number is being formed. All right. Now what will happen? 1 modulus, sorry, 1 div 10. All right, so if I do it 1, so 0 times 0, my remainder will be is equal to 1. Okay, so we don't care about the remainder, but what we require is that this num, because now the condition will become false. So when this particular condition becomes false, what happens is that remainder is not calculated anymore. It will skip out of this particular loop. So when it skips out of this particular loop, what happens? My last value of reverse is 1 to 1. So my chk is 1 to 1, my reverse is 1 to 1. So finally this particular condition is true. Okay, this condition is true, and therefore it is a palindrome. So my output will be is equal to palindrome. Okay, so this is how finally the whole concept is about checking the palindrome of a number. Okay, so let's do one thing now. Let us quickly write the program and see whether the algorithm that we have created is correct or not, whether it's programmatically working or not. Okay, so first my num is equal to the typecast int input enter number. All right, so I'm writing it in short, make it fast. So chk will be is equal to num, then my original value of div will be equal to 0. Now I will check while my num is not equal to 0, my remainder will be is equal to my num modulus of modulus 10. That is the case, then rev is equal to rev into 10 plus the remainder, and this time a num will be is equal to num divided by 10. So my chk, the original number, is equal to my reverse of the number, then print palindrome, else print not a palindrome. I hope I haven't made any careless errors while printing, typing. Okay, let's see if there is an error message. We'll understand the error message as well and we'll rectify. So control S, control run. Let us run this program. Okay, there you go. The shell starts. So let's type 121, enter. Okay, wonderful. The program is running. So it is a palindrome. Let's try out another number. Let's say 1653. Okay, it's not a palindrome because it is 13561, the reverse. Okay, let's try out another number. Okay, 1221. Okay, it is a palindrome. You see, when you read it from the reverse as well, it is a palindrome. Okay, let's try another number. Okay, minus 121. It is not a palindrome, and actually what is happening is that the program has encountered a situation where we have not checked whether a negative number can be tested for palindrome or not. So I leave this task for you. In the next video we will see how we can modify this program in order to check for a negative number whether it's palindrome or not. But obviously a negative number is never going to be a palindrome. Okay, because 1 to 1 minus the reverse of minus 121 is not the palindrome of it. Okay, all right, goodbye. Happy learning. We'll meet in the next video. Okay, try this out.